Welcome everyone to the Unlock the Value of Bluetooth LE for Indoor Positioning. This webinar is brought to you by u-blox and in partnership with Nordic. Just a small information about the housekeeping. This webinar is automatically recorded and will be sent to you. And the presentation will also be sent to you as a PDF. We will have a Q&A session at the end, so you can place your question as shown here. And if we don't have the time to come back to you during the webinar, we will come back to you offline after. So what we will talk about in this webinar, first introduction about the technology. So we will go through Bluetooth direction finding and angle of arrival. Then Nordic Semiconductor will show their contribution to indoor positioning with the NRF 52833 and NRF 5340 chip. Then we will let you know everything about XPLR-AOA Kits. So those are our XPLR kits for indoor positioning and what they can achieve. We'll have a demo and show you how to set it up. And finally, we'll go through use cases. At the end, we'll also show you how to get started with this, and we will have the Q&A session, as I mentioned earlier. Now a little bit about our speakers. First, Pelle Svensson from u-blox. Pelle has very deep expertise in short-range wireless connectivity and industrial automation communication, and has a long experience as a product marketing manager, both for Industry 4.0 and healthcare. Our second u-blox speaker is Eric Karlberg. Eric has expertise in product management and business development of Bluetooth and Wi-Fi modules, and a long experience in wireless communication. And then our guest speaker, Paul Kastnes. He is from Nordic, and he has expertise in embedded system and wireless connectivity, and experience within wireless products as a technical marketing manager, and over 20 years experience in microcontrollers, embedded system, and wireless communication. So now with this, I would like to hand over to Pelle for the technology background.
Okay, thank you, Agnes. You can hear me?
I can hear you.
Okay, good. So a little bit introduction to the technology that is part of this Bluetooth direction finding. We can go to the next slide. Bluetooth direction finding was one of the main features in Bluetooth specification 5.1. It was released more than 2 years ago, and this feature, as I said, was one of the key elements in that specification. Prior to that, Bluetooth LE, Bluetooth Low Energy, has been used for indoor location using Received Signal Strength Indicator, RSSI. This method provides an estimation of the distance between a transmitting tag and a receiving device. As you can see on the upper picture, you have the receiver in the middle, the antenna, and the blue dot is the tag that is transmitting the signal. And the receiver will then see what is the strength of the signal that is received. Knowing the transmit power, it can calculate an approximate distance. But that's it. With the direction finding, the angle from the transmitting tag is also part of the game. It's calculated at the receiver side and provides better accuracy for indoor positioning. Direction finding can come in two different flavors, either angle of arrival, where the receiver has multiple antennas. The receiver is doing the main part of the heavy lifting. It calculates the angle based on these signals from the different receiving antennas. Angle of departure, then it's the opposite way, that the transmitter is doing the heavy lifting. It has multiple antennas and transmits a signal that is received by a single antenna device, more for indoor navigation kind of use cases. Next slide. Let's look at the angle of arrival basics here. You have a simple transmitter, AOA transmitter to the left. It sends out a a radio wave, and a receiver which has different multiple antennas and a switch, so it's reading the antenna signal from one at a time, and includes a constant tone in a transmitting signal. With multiple antennas receiving the signal, they will come in slight different phase. So it's a phase shift depending on the angle from where the signal is transmitted. And the receiver will measure those samples from different antennas, so-called IQ samples that will later on be used for calculating the angle from the transmitter. Next slide. Here are some different antenna elements that can be used depending on use case and accuracy, and also if you want to locate things in 2-dimension or 3 dimensions. The linear antenna to the left is of course used for 2-day angle measurements. The other ones are rectangular with an L shape or a 16 elements in a square or a circular antenna. The size of the antenna is based on the wavelength for Bluetooth direction finding, which is 12.5 centimeters. So you have to have a certain size of the antenna. You can also see some photos of antennas that we have tested in our lab here, and the L-shaped antenna is also part of the kits that's going to be presented by Eric later on. Go to the next slide. I mentioned the IQ samples on the previous slide. It's a signal from each of the antennas that is received and take it into consideration. Now it's time to make the angle calculation. That includes a number of more steps which are not part of the Bluetooth specification. And Nordic will cover this first in depth here, how to set up the frequencies, the constant tone exchange, and so on. But the rest is implemented by each provider of this technology, and of course that has been done by u-blox here. So the process includes pre-processing, filtering, and selection of the incoming data from those dual polarized signals from different advertising channels. We're analyzing the power of all the receiving antenna, and then we do the angle calculation based on an algorithm called PDDA. We have tested various example of algorithms and found this one to be efficient, living well in a constrained device like this module that we're using here, which has an ARM Cortex M4 with limited flash and RAM. Next slide. The final step in the positioning process is to get those angles from various receivers. We call them anchor points that are fixed, located on walls in a facility with known position. Positioning engine uses an algorithm called Triangulation and gets those multiple angles, and with those calculations it's possible to achieve sub-meter level accuracy in the indoor positioning system. Next slide. Describing the tracking scenario. This is the typical positioning using angle of arrival. Here you see 2 anchor points with 4 antenna elements each. A tag is simple single antenna element. The position is calculated centrally in the positioning engine based on the multiple angles received by the different anchor points. This is what we call a network-centric application. The objects are tracked by the system, and the objects are usually not aware of their own location. Next slide. This is the other way around, where the anchors are having the multiple antennas, but they are transmitting the signal, and the tracker is then capable to receive those and figure out, based on knowledge about where the anchors are located, to calculate its own position. This is what we call a device-centric application, where the devices are aware of their location and reports to the position back to users if necessary, but typically used in indoor navigation use cases. Back to you, Agnes.
Thank you so much, Pele. So that was introduction about the technology. And before moving on to Nordic section, we would like to get your view about a few things. So we have a series of questions for you. And the first one is about which connectivity technologies you're planning to implement or have already implemented for your inner positioning application. So here you can select as many relevant answer as you want. So is it Bluetooth RSSI? Is it Bluetooth direction finding? Wi-Fi RSSI find time measurement? Is it ultra wideband or none of the above or not decided yet? So giving you a few more seconds to vote. And then for each of those questions, I will share the answer with you so you can also follow what is happening in the audience. I think it's quite good. So let me now, I will close the vote now and I will share it with you. So it seemed that the Bluetooth direction finding is the technology that you're looking for. And for the rest, you might need to think a little bit more about it. Okay, and then moving on to the next question. So now we would like to ask you, what are your main criteria when selecting technology? Is it low power consumption, position accuracy, total cost of ownership, a large ecosystem and standardized technology, or ease of deployment? Again, giving you some time to answer this question. I also wanted to remind you that we have the Q&A session at the end, but you can ask your question along the presentation. And if we don't have time to answer to you directly during this webinar, we'll take this offline after the webinar. So I will now close the call, the question, and share with you the answer. So it seemed that the position accuracy is the key thing for you, which makes sense here, but also low power consumption and ease of deployment. So thank you for this. And now I will go back to the presentation and hand over to Paul for his presentation.
Yep. Can you hear me now?
Yes.
Yes. So as Pelle has done an introduction on the whole system, I want to talk a little bit about the key parts that we as Nordic bring to the table to enable this kind of technology for our customers and for our partners like u-blox. So next slide. As Pelle mentioned, the direction finding was the hallmark feature. It was the most important thing that was added to the Bluetooth 5.1 core specification, which has been around for quite some time. It was actually adopted all the way back in 2019. What we would like to make sure that everybody is aware of, that this is an optional feature. Like a lot of the new things that when it comes into Bluetooth, they are optional. It means that you can implement it, but you don't have to implement it. So the core specification number allows you to do something. It doesn't force you to do it. So you will find a lot of devices that are certified for Bluetooth 5.1, 5.2, or 5.3 that does not support direction finding. And this is because it requires radio changes that are very specific for enabling this this feature. So I will talk more about the different items in the later slide. We just want to make sure that everybody is aware that it's optional to support this. So next slide. So we started out focusing on the angle of arrival. And the key reason for this is that this is a very good solution for doing what is very people commonly looking for, which is tracking devices in a system-centric solution where you have a very simple beacon, where you have a tag, which is a movable unit, which is a single antenna. And since it has very low complexity, it can be one of the smaller and cheaper devices. The receiver, on the other hand, is more advanced because you have the antenna array on it and the antenna with the switches and everything, and you need to have either the processing power to do the angle calculations of the device, or it needs to be connected to offload the data to somewhere else to get it processed. The key part here is that you will have only a few receivers while you will have a lot of the transmitters. So because of this is a system where the unit you have a lot of is the cheaper device. So we started out with this. We are of course looking into angle of departure as well, but that is a little bit further out in the driven by the market and requirements in the market. So next slide. So I will go through all of the different layers in the build-up to generate the direction finding solution and the things that came in and needs to be added to this, and also talk about what we bring to the table for these different items. So key update that happens when you go for direction finding is that you will need to have an antenna array on one side of the link. So this is a much more complex system than what has been needed before. Earlier, you needed a single antenna for a Bluetooth connection. Now you need to have the array, where you need to have multiple antennas with fast RF switches to be able to change between the antennas really quickly and at a specific timing. And also the array needs to be designed in a way where the phase response of the antenna is not impacted by the angle of the incoming signal. So if the signal is hitting the antenna, the phase shift should be, or the phase response of the antenna should be completely predictable, and it should always be the same, independent on if you move the movable device around. If you don't have this, then it becomes very difficult to make an algorithm that will be able to predict the incoming angle. So there's a lot of different antenna types out there. Some of them behave very well with this. Some of them are not so good. This means that you will need to have quite a bit of experience with antenna design if you plan to make your own antenna array. So it's a skilled operation. This is also why we partner up with third parties like u-blox who do provide these antenna arrays. And you also need to have a good model of the antenna to be able to do the angle resolution later on. So next slide. Also, to be able to support direction finding, you need to have an updated radio with specific new features to be able to get this CTE, which is the continuous tone extension used for calculating the angles. You also need to be able to both to transmit and to receive these ones. You also need to be able to interpret the headers. There's new header information that comes with the solution. And you need to either be able to store the data that comes out of the radio, which is in the form of IQ data for processing later on, or the capability of getting them forwarded out of the device really quickly. And you need to have the support for the automatic control of the external RF switches. All of these ones require hardware changes to the device to be able to support it. And this is why you will see that only some of our devices do support direction finding, because only some of the devices has this upgraded radio with upgraded GPIO control to be able to support all the features needed. So next slide, I will go in a little bit more detail about how this is actually done to make it work. So when you're looking at this is a standard packet for Bluetooth. You have the preamble, you have the access address, you have the PDU, and you have the CRC. The key new thing for direction finding is you have this constant tone extension, which is added to the end of the packet after the CRC. So this one uses a continuous sine wave going through. This is an unwhitened sequence of ones. And this is different from everything else you do in Bluetooth. In Bluetooth, you always whiten the package to make sure that you have clock recovery on the radio when you're running the transmissions. But for the CTE, we turn this off. Also a thing that requires to have hardware supporting it. You can do connectionless as well as connection-oriented modes when you're doing direction finding and append the CTE to both of these. One of the things that happens is that when you do connectionless, it has to be using periodic advertising, which is one of the parts of advertising extension that came in with Bluetooth 5. This is a feature that hasn't been used that much, but is being used now by direction finding, and is also going to be used by Bluetooth low energy audio. And there is support for both the 1 megabit and the 2 megabit PHY. There is no possibility to use coded PHY, so the long range mode, together with direction finding, and this is because when you use the coded PHY, you basically run on the 1 megabit PHY, but you encode the data on top. You wouldn't be able to get any range improvement when you're doing the CTE compared to the 1 megabit mode, because it would still be 1 megabit. So there's absolutely no need for going with the coded PHY, and that's why it's not part of the specification. Next slide. And as I said, there is the PDU header as you do normally, but now there is a new field called CTE info. And if you have this field is part of the header, there is a bit called the CP field, which was earlier unused. Now it tells you that yes, there is a CTE info field. When the receiver sees this, it will parse the CTE info field and then set up the radio accordingly. And this defines the length of the CTE, what type it is, if it's AOA or AOD, and so on, and if what kind of switch slot duration is. There's a couple of different options here. Since this has to go real time and you have to reconfigure the radio based on the CTE info field, you need to have this as a hardware function inside the device. So this is also one of the big updates we had to do, is to automatically detect this and reconfigure the radio on the fly to take in the packets. So next slide. And this is where you can see that this is just to show you how the continuous transmission looks, and a lot of different options you have for setting this up. And as I said, the CTE range is adjustable. It can be as short as 16 microseconds, but it can also be as long as 160. So you can have, depending on the accuracy you want, the number of antennas you have, and so on, you can change this. You need to have minimum 2 antennas. We support up to 39 with our solution. And this is also given by the time, how much time you have for each of the antennas. And we automatically detect how this is going to be done. And then we switch between the different antennas in a predefined sequence, which is set by software based on the timing here, and automatically switch GPIO pins to control the external switches to make this work. So there's a lot of hardware that has been added to make to be able to support this solution. Next slide. And then when you get slightly higher up in the stack, you get to the Bluetooth controller. We had to add functionality to the controller as well to be able to support direction finding. We need to be able to configure the RF peripheral in the device to be the receiver transmission and enable the AOA or AOD, and also to be able to set up the pin control. So all of these data will be coming from the application through the host into the controller. So we need to have the control for it here. We also need to have the possibility to push the IQ data from the controller side up to the application. And as well, we had to add periodic advertising. And next slide. On the host side, we also need to do the same thing with the configuration, enabling the application to push through if you want to do the receiver transmitter, if you're going to do AOA or AOD, and also how the antenna array is configured. So which GPIO pins are being used for controlling the RF switches, which sequence are going to be done. And also you need to be able to pull the IQ data from the controller and pass it over to the application. And actually, this is the endpoint of where the Bluetooth 5.1 specification when it comes to direction finding. So the IQ data, which is the data coming from the radio with all of the different phase information, is the end stop. Everything that happens after this, the angle resolution algorithm and so on, is not part of the Bluetooth specification. So this is something that has to be added on individually for each of the systems. And of course, again, we added support for periodic advertising. So next slide. On this side, when we're doing this, we have some reference samples in our SDK, where we have an application where we configure up the radio, where we configure up for a specific antenna array. We provide this as a template so people can see how to set it up on their own side. and then it will receive the IQ data from the Bluetooth controller and being able to process them afterwards, either to add an algorithm that will calculate the angles based on the IQ data on chip, and or secondary to transfer the data to the external processing unit. So you have the option of doing both here. We only provide an application that actually does the receiving of all the data or the transmitting of all the data, and everything beyond that is up to the end user. So next slide. So when you look at all of these things, there are a lot of things that needed to get things working. The antenna array and the application are tightly connected, so you need to change the application based on the antenna array, which means that it's difficult for us to provide samples for it that will work with everything. So we focused and pushed all of our efforts into doing the radio hardware, the Bluetooth controller, and the Bluetooth host, because these parts are more or less unchanged over all of the designs, which means that we will be able to provide a Bluetooth 5.1 compliant Bluetooth host and a Bluetooth 5.1 compliant controller with the direction finding support with these ones, and we target to qualify these ones, so you will get the QDIDs and everything to build the Bluetooth designs using this and register them with the Bluetooth SIG, and we target to qualify it by the start of 2022. And because of the linking with between the array and the application side, we expect partners and customers to deliver the antenna array design, the application code, and the angular resolution algorithms. And this is why we are very happy to join up with u-blox, since they are doing this and providing it to their customers. We are taking care of the pieces that require a lot of Bluetooth expertise, and we provide the code for them, so they can just integrate it into their design. They don't have to worry about this and care about the qualification of the stacks and so on. Next slide. So we have a lot of devices that do support direction finding. They all have the same hardware support inside them. They do support the automatic parsing. They support for both for Bluetooth and for proprietary solution. They handle the IQ samples. You remove the data directly into RAM. We do support what is the Bluetooth standard way of doing IQ sampling, which is 1 megasamples, but we also support oversampling to 2, 4, and 8 megasamples. So you have the opportunity to go with a higher resolution. It may give you advantages when it comes to having easier to build the algorithms and so on. And we also support data formats in the standard Bluetooth, which is 8-bit, but we also go up to somewhere around 10, 11-bit with actual performance coming out of the device. And we support up to 8 GPIO to control external switches and 38 configurable switch patterns. And we do that on all the devices. So we supported that support direction finding. So the 52811, the 52820, and the 52833 and the 5340, they all support all of this. But if you look at the parts, the 811 and the 820 have smaller RAMs than the two other devices, which means that they are not really suitable for being receivers. You can't really store all the IQ data and do all of the processing on them. So the recommendation for this is to use the larger devices, the 833 or the 5340 for the receiver side, and use the 811, 820 on mobile tags. They have more than enough capabilities to do all of that. Then next slide. And this is just to highlight the fact with the dependency and why we have picked the area that of delivery from our side that we do, where we provide the controller and so on, is because the array and the algorithm are tightly connected together, and you can't change one without changing the other. So we're seeing that these needs to be developed together as one unit. Okay, I think that was all of my slides.
Thank you so much, Paul. Yes, it was. So it was very interesting for us to know more about one key element here, configuration. So thank you for that. And now we'll go for another question to the audience. So we would like to know which application is of interest for you for indoor positioning. Is it asset tracking, people tracking, indoor navigation, access control, or if there is any other application? All right, so just giving you some more seconds to answer. And also wanted to remind you that we have the Q&A session at the end, so feel free to start asking your questions now. I will now close the vote for this question, as we have a couple of more I would like to ask you and I want to share as well. So for this one, it seems like asset tracking, people tracking, and yeah, indoor navigation are the top three. So thank you very much for this. And next question, we would like to know what is your yearly consumption of modules for indoor positioning in this context. So is it less than 1,000 units? Is it between 1 and 20,000 units, or is it over 20,000 units? Giving a few more seconds for you to answer. And I will now close the vote, and the answer is less than 1,000 K as the majority. And then now last question, and then we will be done with our question for today. And again, thank you for answering so quickly and so many of you. So according to you, what are the main obstacles to get an indoor positioning system in a facility? Is it the cost of ownership? Is it the complexity of installation? Is it if it's commercially available, if the product or solution are commercially available, or is it because it's difficult to select the appropriate technology? It seems like it takes a little bit more time for you to answer on that question. But again, we're very thankful for your engagement here. It's very interesting to see. I will now close the vote and share the answer. So it seems that the complexity of installation and the commercially availability are the top two concerns you have. Okay, thank you very much for this, and now we'll go back to the presentation, and I will hand over to Eric. We'll go into the XPLR-AOA Kits.
Thank you very much, Agnes. So we will talk now about two XPLR-AOA Kits that we put together, and these contain all of the exciting technology that Pelle and Paul has talked about in the previous sessions. So if we go to next slide. So the thinking here is that we will have these XPLR-AOA Kits to lower the threshold to evaluate the Bluetooth direction finding technology. It includes everything you need to try out this new technology, and it serves multiple purposes. You will get familiarized with the technology, you can develop proof of concept implementations, and discover new use cases and applications. So the first kit we call XPLR-AOA 1, which is aiming at providing the angle of arrival data to the user. So it includes an antenna board and a tag. And the angle is calculated in a software that we call Uconnect Locate, where we implemented an optimized AOA algorithm. And this angle is calculated in 2 dimensions, both azimuth and elevation. And the board also contains, the antenna board also contains a LED array on the right side of the board there, you can see in the picture. And this array is formed in a cross and will light up the LEDs to indicate the direction to the tag. So it's easy to see in which direction the tag is coming from. The kit also contains software example for the tag that is set up to transmission these advertisement signals with a constant tone extension that Paul described. We can go to next slide. Looking at the XPLR-AOA kit, the second kit, and this is geared to the indoor positioning use case. It contains 4 antenna boards and 4 tags. It also uses the Uconnect Locate software to calculate the angle from each of the antenna boards. And these angles are then fed into a positioning engine software running on a PC, which calculates the position of each of the tags. We can go to next. And all of these are built using our Nina B4 series of Bluetooth modules. So these are modules that are Bluetooth 5.1 qualified. They are based on the Nordic Semiconductor nRF52833 SoC that Paul showed. It has options for internal or external antenna. You can run them as an open CPU, meaning that you will develop your own application using the Nordic software development kit, or you can run them with the Uconnect software, which allows you to easily control it through 80 commands. And they are globally certified. Specifically for direction finding, we have developed the Nina B411 variant. And this has an antenna pin underneath the module that connects to the antennas directly for the best performance. It also runs this embedded angle calculation algorithm in the Uconnect locate software. And if we go to this slide, yep, thank you. We have some more information about the Uconnect locate software. So this is supporting angle of arrival. And the idea here is to really lower the threshold and getting faster time to market for Bluetooth positioning products. It leverages the embedded MCU in the module in the SoC, the Nordic SoC. So it's the algorithm is running completely inside that MCU. So there's no need for any external processing on the host board. As you can imagine, in an indoor environment, there is a lot of reflection and multipath components that you need to take care of. So we've built that into the algorithms to suppress those multipath components and only focus on the direct paths. And everything here is controlled by an easy-to-use API. And then looking at the positioning engine software, so that contains of two parts. Well, first, on the left-hand side, you see the angle data coming in from the different anchor points. That is fed to the positioning engine, where trilateration of the angles allow you to have a 3D positioning support. And when that position is calculated, it's fed to a user interface, it's a web-based user interface, where you can track the tags. And this interface is also used for configuration. You upload a floor plan. You'll see an example here of our coffee area in the u-blox office. And you can configure the anchor points, and then finally you track the tags. If we go to next slide, we have another option here, and that's to connect the positioning engine part to professionally available and commercially available asset tracking platform called Traxmate. So the positioning engine has an integrated connection to the Traxmate asset tracking platform. You register directly through the tool for the web-based UI, and there is a trial license to Traxmate included with the kit. And this support, we're right now wrapping that up, and we will provide that will be available through download from our website u-blox.com in October, later this month. So Traxmate, that's a complete enterprise asset tracking platform that we've partnered with to provide this really nice user interface and an environment for tracking your assets. So you can create your buildings here, you upload the floor plans, you manage the placements of the anchor points, the Bluetooth anchor points, or if you have Wi-Fi access points and use Wi-Fi for location, you do that for this tool. And here we have recorded a video where we demonstrate how you set up the XPLR-AOA kit with the Traxmate platform and start tracking your assets.
Today we're going to show you how to set up the u-blox XPLR-AOA Explorer Kit for high accuracy indoor positioning with Bluetooth angle of arrival. The kit contains antenna array boards for the static anchor points, tags for the objects that we'll be tracking, and all the software needed to visualize their positions on a map. To make deployment smooth and efficient, we'll be using Traxmate's asset tracking platform. which comes with integrated support for the u-blox XPLR-AOA 2 Explorer Kit. This is where we'll be setting up the indoor positioning system. In this case, we will be using Wi-Fi to transfer the angle estimates from the anchor points to the local positioning engine. To deploy the system, we open the positioning engine software and log into the Traxmate platform. The next steps, which we did behind the scenes to save time, involve uploading a map of our building to Traxmate and positioning our anchor points. Traxmate makes it easy to configure details such as each anchor point's height and tilt. Once all the anchor points are deployed and configured, we're ready to start tracking. If we now grab a few tags and start walking around the office, their positions are displayed in real time in the Traxmate tool. The XPLR-AOA 2 Explorer Kit gives you all the components you need to set up and evaluate Bluetooth indoor positioning. Learn more about the technology and the Explorer Kit at u-blox.com. And get your own Explorer Kit today from our web shop or through our distribution partners.
Okay, and then on the final slide from my side here, just a sneak preview onto what's next from us in this area. So we have the XPLR-AOA kits that are for evaluation of the technology, and we're now moving to the next stage where we have a new antenna board coming. It has more elements, providing a more robust performance. It has improved RF design. It's designed for integration in end products compared to the existing boards that are more for evaluation, but we'll still keep the same small size. So stay tuned for more news about this.
Thank you, Eric, so much for this presentation. And now handing over to Pelle for looking into the different use cases.
Okay, can you still hear me?
Yes.
Good. So let's have a look at some use cases that are enabled by this Bluetooth direction finding technology. The first one is a follow me use case where you have a device, and the picture is a picture as a camera, and you have a person. In this case, the camera will have the receiver with a multiple antenna array, and the tag will be worn by the person. It can either be in 2 or 3 dimensions depending on the antenna array being used. Example of devices here could be an air purifier that is blowing fresh air in a certain direction, fans following a person, or even maybe a golf cart following a person on a golf course. Next slide. In this scenario, we have 2 mobile devices. Both has to, in this use case, have both the transmitter, the tag, and also the anchor points in order for both of them to detect the distance and the angle from the other moving objects. And the application here is basically to avoid coming too close and avoid collisions. Next slide. Another one with one angle calculation only is a garage port or garage door with an angle of arrival receiver, and a forklift here has the tag transmitting the signal to the receiver. And the forklift can either be passing by or approaching the gate, and depending on how the angle is changing in time, the receiver can make an assumption that the forklift is approaching the door from the inside or from the outside and open automatically if that is the case. Next slide. And here are some asset tracking use cases where multiple receiver anchor points needs to be installed in a facility where you want to track asset and people and etc. It's probably one of the most popular application that we see among our customers we're talking to. The goal here is, of course, to track different physical assets and objects and their location within a specific facility. Example of applications are in a medical facility, in a hospital, tracking medical equipment, knowing where things are, the expensive emergency equipment needed in fast, very quick time, or even track doctors and nurses to know where they are, so we can quickly alert them to come to a certain place. In manufacturing facilities, like a manufacturing site, track for the efficiency of production line, knowing the location of material to be used in the assembly line, as well as tools being used by people in the assembly line. In a retail, analysis of consumer behavior, in a commercial setting, tracking shoppers' behavior, where are they moving around in the supermarket. And finally, in the warehouse, knowing where inventory are located at all times, logistics tracking and for inventory and shipments. And once you have collected the position of objects, in this case a forklift, and you save those in a historical database, you can later on do some route optimization. So there is an example on the upper image here where the forklift has been passing through the main floor here in the building 4 times, which could be considered as a little bit inefficient. Instead, when knowing this is happening, you can reroute the traffic to go the shortest distance between the machines and then do one pass over the main floor. So tracking and historical data can be used for route optimization. Finally, people tracking in a construction site, for example, each worker uses have the tag attached either somewhere on the belt on the body or on the helmet, and you have anchor points surrounding a dangerous area, so you can keep track of that no one is entering that hazardous area, or in an emergency situation, being aware and identify who has left the building in such a case. Now back to you, Eric.
Thank you, Pelle. So just a few slides to wrap this up and some information on how to get started. So we have technical information available on our web pages for the products, so the XPLR-AOA 1 and AOA 2. There's also a dedicated technology page for Bluetooth indoor positioning. And if you really want to go into the details, we have a webinar, an earlier webinar that we held back in January, which goes into the details about how the positions are calculated. Then software-wise, we have the Uconnect locate software that's available to download from u-blox.com. Also, the positioning engine is available from our web, and the tag example software that's available in source code from GitHub. And if you want to order your own Explorer kits, you can do that from the u-blox web shop or through our distributor partners, Mouser and DigiKey.
Thank you very much, Eric. So now over to the conclusion of this webinar. What are the key takeaways we hope you will get from this? First is that Bluetooth 5.1 refines indoor positioning with direction finding and the AOA, angle of arrival. Then secondly, that the configuration is key to efficient and reliable indoor positioning systems. then that there are that industrial remains a crucial market, but use cases can cover various segments. And finally, the XPLR-AOA Kits and Uconnect software help you get started today. So with that, we would like to start the Q&A session. So we can put a little bit of the webcam up and then also some pictures so you know who are the specialists answering your questions today. We have, of course, Eric, Pelle, and Paul, who just spoke, but we also have Björn Kvale from Nordic Semiconductor, as well as Ricard Wind from Traxmate. So let's crack on with all the questions. We have quite many actually, which is very good sign. Let me see. So maybe I'll start with a question for Eric. What is the physical size of the L-shaped antenna? That's from Joachim. Eric, we don't hear you. You're on mute.
Sorry, I was mute. That's 11 by 11 centimeters. That's the size of that one.
Super, thank you. Moving on to the next question. That is for you, Paul. What are the constant tones transmitted, or are the constant tones transmitted all the time or in bursts? If continuously, what is the impact on the energy consumption and autonomy of the tags?
So this is depends on the configuration. So they are appended to the end of Bluetooth packages. So it will be the same as when you do a Bluetooth beacon. It depends on the connection interval or the advertising interval you set up. The longer advertising interval, the lower power consumption is. And if you consider the time, the longest CTE frame can be 20 bytes or equivalent to 20 bytes. So it's not a lot. So it won't impact that much. If you compare it to a normal beacon, it will use maybe 1.5 times the amount of power. So it's not too bad. And because of this, you can also get very long battery lifetime on battery operated devices for the tags.
Actually, I think we had a question about this, but let's get to that later. Now moving on to next question for you, Eric. Can several devices be tracked simultaneously, for instance, to measure relative distance and angles to each other? That was a question from Henrik.
Yes, they can. So we're currently supporting up to 64 tags tracked simultaneously, and then the 64 active tags. And then of course you could have more if you let devices that are not moving sleep, for example, and not send CT messages. Then you can track even more, have even more tags active in your system.
All right. Now, question for you, Paul. Do you supply SDK so that the mobile phone can be used as a tag?
No, we don't do that, because to be able to do it, then the phones need to support AOA or AOD. They need to support the CTE part, and currently no mobile operating systems support it. So because of that, we won't be able to do apps. As soon as that becomes supported, we will make apps.
Good. Next question still for you. Is there an application note covering best antenna design practice to suppress potential multipath effects?
What I can say is that we do not have an application note like this, and this is how to say, a very specialized skill. It's not something where you can easily say the thing you can get is a full fixed design, or you will have to do it from scratch and do the measurements, which takes quite a bit of time. And this is why we always recommend to start out with by hiring services if you don't have the skill set in-house. It can take quite a bit of work to make them a good antenna.
Thank you. Next question for Pelle. Can Uconnect locate software be used in combination with NRF5 SDK running other Bluetooth services? And that's a question from Henrik. You're on mute, Pelle.
Sorry, now the Uconnect locate is pre-flashed into our NINA B4 modules and cannot be combined with the OpenC concept of customers adding their own software on top.
Okay, thank you. Next question for Eric. What is the typical range and angular accuracy?
Well, the typical range, I believe we've seen 20 to 30 meters range, but it will all depend on what accuracy you want to have in your system. So the better accuracy, the more densely you will populate your anchor points. And the accuracy that we see is that we definitely see it below sub 1 meter accuracy. We've done a test installation setting up 4 anchor points in an office with a 6 by 8 meters rectangular shape, and we had a accuracy that was a 95% probability better than 1 meter, and with 50% probability better than 0.6 meters. So but it all will depend on how densely you populate your anchor points in the area.
Okay, thank you. Next question. This is for you, Ricard. How do we get a copy of Traxmate?
Yeah, that was a nice question. Thank you very much. Actually, if you buy the start kit, the AOA number 2, then you will have Traxmate included in that one. So there is an evaluation license. You can test Traxmate by using that start kit. So, and then Traxmate is a cloud service, so you can always, of course, register and use Traxmate that way as well. And then later on, for commercial deployment, then Traxmate will be available for on-premises installation as well. So you could have your own copy of Traxmate running in your own infrastructure as well in the future.
Good. A question for you, Eric. What u-blox module is suggested for the tag? That's from Douglas.
Well, for the tag, we have modules based on NRF 52811. That's the BMD 360, sorry, the BMD 360, or you can use the NINA B4 series that is using the NRF 52833. So, and also if you want to have a more powerful tag, we have the NORA B1 that is using the NRF 5340. So there are many options on Bluetooth on modules from u-blox, depending on how much calculation and processing power you will need on the tag side.
Thank you, Eric. And next question for you, Paul. I think you started to answer earlier, but the question is how long lasts the battery from the tag? And for example, the short demo, or maybe that is for Eric then.
I can probably answer it. It depends. It depends on the advertising interval we use. If you use a very short one, the power consumption will be higher, but you will also get a much more responsive system. If you make it, if you have a longer advertising interval, then you get lower power consumption. You can run for years on a small battery. And this is also why you see very common for these kind of solutions where you have a motion sensor in them. So if they are static, you have a long advertising interval. If you start moving it, you shorten the advertising interval, then you can track it dynamically so you don't spend power when you don't need to do it, and so on. And we have seen solutions like this where they run for years on coin cells.
Okay. Actually, I don't know if we have time maybe for one last question. This is for you, Eric, from Douglas. We used the BMG 350 in one of our devices. If we want to enable it as a tag in the future, which u-blox module should we use? I guess it's a bit similar to the previous one, but
Right. So that will be then the BMD 360 for the kind of least complex option. Then the NINA B4 series would be the mid-range option, and then the NORA B1 will be the high range option for the tag. That's all of those three supports direction finding Bluetooth 5.1.
Super, thank you everyone. We presented, and for this Q&A session we have actually lots of questions we couldn't answer, so we'll definitely come back to you after the webinar. And again, this webinar will be sent to you as well as a copy of it. So thank you very much for your time and engagement, and looking forward to hearing from you soon. Have a good day and a good evening. Thank you. Bye.
Bye-bye.
Bye.
Bye bye.